Hi, welcome back to 345 Delta Foxtrot. My name is David Forgerson. This video is part 2 of a 2-part series on spray painting. Part 1 was about equipment and tools, and this video is going to be about how to set up a paint spray gun, or actually a paint spray system, including the air compressor. This channel is basically about building an airplane, building an RV10. This particular video is not airplane specific. If you're just interested in spray painting, no problem. This is just going to be about spray painting with just a little bit of application to an airplane. But it should be generally applicable to most anybody that wants to spray paint. One other thing about this video is it does have some math. If I go too fast, I'll piss off one group of people, and if I go over the math too slow, I'll piss off another group of people. So I'm going to try and go right in between and piss everybody off. But that's about all I can do. You can leave questions or comments, and maybe I can answer some questions or something if something is not clear. But I gotta basically move along because this is going to be a fairly long video. Okay, there's two basic types of paint sprayers, the airless and the pneumatic. This is an example of an airless paint sprayer. They're fairly simple to use. They don't have a lot of controls, and I'm not going to talk about them hardly at all. To use one, basically you just select the spray tip that you want, and it's almost certainly going to come with the appropriate spray tip for latex paint. So that should probably get 99% of the people started. And it's easy enough. Just read the directions or whatever. If you're spraying something other than just normal latex, it'll tell you what tip to use. Then all you have to do is put the little tube on the bottom in a bucket of paint, adjust the pressure. There's a pressure knob on the left side of the compressor there, and I think it's pretty easy to adjust. Typically, when you're using one of these, you're painting something big, like the side of your house. And so all you have to do is set the pressure to halfway or 3/4 of the way open and paint a little section, 2 feet by 2 feet would certainly be enough. If you think you need a little more pressure, just adjust it. But I think you're going to be able to get pretty close pretty quickly, and you're going to find that it's pretty easy. The big thing about, in my opinion, the big thing about airless paint spray guns or systems or whatever you want to call them is the cleanup. These things compress the paint They don't use compressed air. They compress the paint directly. So that means that there's paint in everything, from the can all the way to the tip. There's paint in the small tube. There's paint in the compressor itself. There's compressor in the 50-foot hose going from the compressor to the spray gun. And then, of course, there's paint all in the spray gun itself. And you got to clean all that up. That's assuming that you ever want to use this thing again. And this particular one is $800, so probably you're planning on using it again. And if you don't get it fully clean, the paint will harden, and next time you go to use it, you're going to end up with a mess. It may not work at all. So follow the instructions in the manual, and whatever it says to do to clean it, do at least that much. That should be the absolute minimum amount of cleaning that you do. And you may want to double it. Do whatever you can to get it really clean. Now, this particular model, it comes with an attachment which you can connect to a garden hose, and that's going to help a lot. The cheaper models don't have that, and typically what you do is you flow, you take a bucket of water, you replace your bucket of paint with a bucket of water, and you flow water through the system that way. But I'm sure that it's much better and faster with the garden hose. But of course, it's also more expensive. So that's about all I have to say about airless paint sprayers. This is what I really wanted to talk about, and that's pneumatic sprayers. And the one that I have is, the spray gun is an R500, and that's an LVLP spray gun, which stands for low volume, low pressure. The primary alternative is HVLP, which is high volume, low pressure. And volume is referring to the amount of air that it uses. So this is supposed to use less air than what you might call a normal HVLP spray gun. And my air compressor is a 26-gallon cobalt compressor. Nothing special about it. It is on the large end of the small air compressors. It runs off of 115 volts, and that's what I call a small air compressor. A large air compressor would run off of 230 volts. Okay, this is a picture of the R500 spray gun, and it has 3 knobs: fan, flow, and air. Typically, what you do is you set the air knob full open, and then you attach an air regulator, and that's also shown in the picture here, to the spray gun, and you adjust the amount of airflow using the air regulator. And that works well, and I recommend doing it that way. And typically, a nominal pressure for a spray gun like this would be about 30 psi. So that's a good starting point. Now the fan controls the spray pattern. If the fan is all the way off, you're just going to get a round spray pattern. As you start opening up the fan knob, you're going to get an oval-shaped spray pattern. We'll go over this in more detail in later slides. Now the flow knob is just a stop for the trigger. When the flow knob is fully counterclockwise open, then the trigger can be depressed the whole way. If you turn the flow knob fully clockwise so that it's closed, then you can't pull the trigger at all. Okay, this is a close-up of the nozzle and the cap, and this particular nozzle, the hole in the center is 1.5 millimeters in diameter, and that's a fairly typical size for paint. If you're painting a car, your primer and your base coat are probably going to use something like a 1.5 millimeter nozzle, and maybe your clear coat is going to use a 1.3 millimeter nozzle, something like that. The holes around the edge of the nozzle, there's 6 of them. You can only see 4 in the picture there. That's the air for the fan. And the air and the paint are going to come out the 1.5 millimeter hole in the center. And that's just a round hole, so it's going to come out in a round pattern in a cone shape. And the air to change the pattern shape is coming out these holes around the edge. And as it is, you would still end up with a round pattern because the air is coming out all around, basically symmetrically. So what you do is you put a cap over the nozzle, and that's shown in the bottom picture here. And the cap redirects the air for the fan, or the fan air or whatever, so that if the nozzle is in the orientation shown here, the fan air blows in from the 2 sides, from the left and the right, and it pushes the paint cone to form a vertical oval. Like I said, in later slides, we'll go into this in more detail, and you'll be able to see pictures of what's actually going on. The picture here is a 1.3 millimeter nozzle. Sorry. Okay, spray painting with a pneumatic spray gun is all about the air. It's actually about the paint and the air, and I would say it's about 80% about the air and 20% about the paint. So the air is a big deal. The air compressor that I have, as I've already said, it's a 26-gallon Cobalt, and the spec says that it can deliver 4.5 standard cubic feet per minute, that's SCFM, at 90 psi. And my spray gun, the R500, the spec for it is 3.5 to 3.9 cubic feet per minute at 30 to 50 psi, basically. So the question is, do we believe these numbers and what they really mean? So that's what we're going to talk about. Okay, step 1 for setting up your spray gun is we're going to start with the compressor, and step 1 is to drain the tank and get any water out of it. Now, this is particularly important if you're not using water-based paint, but even if you are using water-based paint, you still want to get all your water out of your air. You want clean, dry air. So if you have a water filter on your air compressor, you want to drain that as well. If you don't have a water filter on your air compressor, now's a good time to add one. And then step one is, now that you have the tank drained, is to refill the tank and time it. And this is what I got for my tank. It took 5.3 minutes. Now, of course, I measured that in minutes and seconds. And I hope that everybody knows how to convert minutes and seconds to decimal minutes. It's a pretty simple calculation. And the pressure actually went a little bit higher than 140 psi, but I stopped my stopwatch when it got to 140 psi. The max pressure was about 145 psi. So we know that it's a 26-gallon tank, and we know that there's 7.48 gallons per cubic foot. So you just take 26 divided by 7.48, and that's a 3.48 cubic foot tank. And when we were done filling the tank, we basically had 3.47 cubic feet at 140 psi. And what you really want to know is how much air was in the tank at 1 atmosphere, or conversely, if you were to take the tank and use it to blow up a balloon, how big of a balloon could you blow up? You know, the inside of a balloon would just be at 1 atmosphere. So that is 3.47 times 140 divided by 14.7. There's 14.7 psi in 1 atmosphere. So in this particular case, you could blow up a balloon, a 33.05 cubic foot balloon. And then all you have to do is divide by the time. So 33.05 standard cubic feet divided by 5.3 minutes is 6.24 SCFM, standard cubic feet per minute. And now you have an estimate of the capacity of your air compressor. Now, it turns out that with just very little more effort, we can get a much better estimate. So all you have to do to get a better estimate is you empty your tank, and then when you refill it, you just record the time for the tank, the pressure in the tank to reach 20 psi, 40 psi, 60 psi, etc., all the way up to 140 psi. And then you just do the same calculation that we did before. So just pick some random row in this table here, 100 psi. It took 3.37 minutes to go from zero pressure to 100 psi. And we know that the tank was 3.48 cubic feet, and 3.48 cubic feet at 100 psi is 23.65 standard cubic feet, or cubic feet at 1 atmosphere. And then you divide by the time, and that is 7.02 SCFM, standard cubic feet per minute. It's the same calculation that we did before. You're just doing it for each of the different pressures. Now, one thing to notice here is that the flow rate, SCFM, is going down as the pressure goes up. And that's because it is more difficult to pump 1 cubic foot of air into a tank at 140 psi than it is to pump 1 cubic foot of air into an empty tank. That's just kind of common sense or whatever. Otherwise, you would just pump your tank up to 500 psi or something close to its breaking point. But the compressor is having to work harder and harder as the pressure goes up, and the compressor is getting hotter and hotter. And if you don't shut your compressor off at some point, you're going to wear it out. So that's why you only pump your tank up to, in my case, it's about 150 psi max. Some air compressors go higher than that. I don't think they typically go higher than about 200 psi, though. Okay, so we see that the flow rate of the compressor, the SCFM, is decreasing as the pressure increases. And we didn't really take that into account properly. We can do a little bit better job than that. And that's this next slide. Okay, what we really want to look at is the change in pressure divided by the change in time. So the table on the left is the table that we had in the previous slide. So all we've done here is a few more calculations. So the first column in the table on the right is the change in pressure. So let's just pick a row at random. The third from the bottom that was going from 80 psi to 100 psi. So P2 was 100 psi, and P1 was 80 psi, and so the difference is 20 psi. And the time to go from 80 psi to 100 psi was 0.78 minutes. And then you subtract the cubic feet number in the 1, 2, 3, 4 in the fifth column of the first table for 100, which was 23.65 minus 18.92. That's the number for 80 psi, and you get 4.73. And then you just divide by the time, and that gives you the standard cubic feet per minute. And for the case that I've been talking about, it's 6.04 SCFM. And you just do that same calculation for each row in the table in the right here. And now you can really see what's going on. When the tank is empty, the compressor can fill the tank, can increase the pressure in the tank by 20 psi at a rate of 8.87 cubic feet per minute. When you get up to the 120 to 140 psi range, that rate has dropped off by about a factor of 2. To increase the pressure by 20 psi from 120 to 140 psi, the compressor can only do that at 4.73 cubic feet per minute. So this is really how the calculation should be done. And the spec for this compressor is 4.5 CFM at 90 psi. So what we want to do is we want to look at the 100 minus 80 row in the table on the right, because that's basically 90 psi. It's halfway in between the 100 and the 80. And what we got was 6.04 SEFM, which is a little bit higher than what the manufacturer specs, which is a little bit, it kind of surprised me a little bit, because typically manufacturers exaggerate the capability of their equipment. But in this particular case, it looks like they were fairly conservative. And the compressor can actually produce about 6 CFM. Now, maybe with time and use, that number is going to go down. And they don't want people returning the air compressor if it goes down a little bit, or making a warranty claim or something. So now we have a very good estimate of what our air compressor can do. And what we want to know now is, what does our spray gun actually need? So that's step number 3. What we're going to do in step 3 is the same thing that we did in step 2, except backwards. Instead of looking at what it takes to increase the pressure in the tank, we're going to take a look at how the spray gun drains the tank, how it decreases the pressure in the tank. So we're going to be doing the same calculations, but basically just going in the opposite direction. Okay, so to start out, what I did anyway is I set the flow knob to full open. To do that, I've already kind of described how to do that. You just pull the trigger and start closing the flow knob until it hits the trigger. Okay, and then what we're trying to figure out here is just how the flow knob works. You close the flow knob until it hits the trigger, you release the trigger, and then you keep turning the flow knob clockwise until it is full off. And the question is how many turns is that? And in my particular case, that was 4.5 turns. So that's the problem with the flow knob. Say your flow knob has numbers on it, 1, 2, 3, and 4. You cannot just set the flow knob to 3. You have to know what turn you're on. Is it 2 turns full open and then around to 3? Or is it 1 turn open and then around to 3? In my particular case, it's 4.5 turns. So probably different spray guns are going to be different. So you're going to want to play with your spray gun and find out how much adjustment of the flow knob you have. Okay, to measure the air consumption of the spray gun, this is what you do. You set the flow knob to full open, as I just described in the previous slide. You set the air knob to full open, and you set the air pressure with your pressure regulator to 30 psi. You start with the fan fully closed, and you fill the air compressor tank to a pressure greater than 130 psi and turn it off. We do not want it coming on and adding any additional air to the tank. We just want to measure the drain rate of the tank. And there's nothing magic about the 130 psi number. If your air compressor doesn't go that high, just pick a slightly lower number. Okay, then connect the spray gun to the air compressor. We don't need any paint or anything. We're just going to be spraying air. And then you pull the trigger on the spray gun and you time it. And you time how long it takes to go from 130 psi down to 100 psi. And that is just a convenient time, in my case, to use. If you go from 130, to a lower number like 80 or something, everything is just going to take longer, and you're just going to be standing there forever. So you don't want to go too long, but you don't want to go too short either, because you want to be able to measure the time reasonably accurately to, plus or minus a second or two. So that's just the values that I used because it was pretty convenient. And so you stop your stopwatch when the pressure goes down to 100 psi, but let the tank pressure go down a little bit lower than that. Then you turn the compressor back on, and then you time how long it takes the compressor to build the pressure back up from 100 psi to 130 psi. And again, you let the pressure go up higher than 130 so that you're all set for the next measurement. So steps 1 through 8 describe what to do for fan fully closed. And then step 9 is you just repeat steps 7 and 8 for different fan settings. These settings that I used were a quarter turn open, a half turn open, 3/4 of a turn open, 1 full turn open, and I went all the way up to 2 full turns open. And this is the same calculation that we did before, but it's a repeat because I want to make sure that everybody understands what's going on here. The time to go from 130 psi down to 100 psi was 5.92 minutes. And again, like I said, I picked those two pressures so that I wouldn't have to wait longer than about 6 minutes. And then the time to refill the tank to go from 100 psi back to 130 psi was 1.17 minutes. And then the number of cubic feet in the tank at 130 psi is just the 26 gallons divided by 7.48 gallons per cubic foot. So that's the number of cubic feet that the tank is. And then you multiply that by 130 psi divided by 4.7 psi for 1 atmosphere. And you get 30.75 standard cubic feet for a pressure of 130 psi. Do the exact same calculation for 100 psi and you get 23.65 standard cubic feet. And the difference in standard cubic feet between 130 psi and 100 psi, you just subtract. 30.75 minus 23.65 is 7.095. And now all you have to do is divide by the time. So the time to drain the tank was 5.92 minutes. And so the spray gun is draining the tank at a rate of 1.20 standard cubic feet per minute. And the compressor is refilling the tank at a rate of 6.07 standard cubic feet per minute. Okay, let me change this so you can see the table. Okay, this is just the same calculation done for different fan settings. Like I said, I went from a fan fully closed up to 2 full turns open in increments of a quarter turn. And the second column just shows the time that it took for the spray gun to drain the tank by that 30 psi. And then the third column is the time that it took for the compressor to refill the tank. And the compressor is doing exactly the same thing in every single case. So you can just take the average. The average time for the compressor to refill the tank is 1.17 minutes. And you could see kind of how accurate I was with the stopwatch. I wasn't using a digital gauge or anything. I was just reading this off the analog gauge on the air compressor. But even so, I was able to get, pretty repeatable numbers. We know that the capacity of the tank is 7.095 standard cubic feet. So all we have to do is take that and divide by the time. And we already did the calculation for fan equals 0, fan fully closed. And that was 1.20 standard cubic feet per minute. And the compressor is refilling the tank at about the average is 6.07 cubic feet per minute. And of course, as you open up the fan, it's using more and more air. So if you open up the fan more than one full turn open, if you go to 1 1/4 turns open, then the spray gun is draining the tank at a rate greater than the compressor can fill the tank. The drain rate is 6.55 and the fill rate is 5.91, or the average is 6.07. So the compressor is not able to keep up with the spray gun. So that's why the fan settings of 1.25 and higher are highlighted in red. And you can also just see that from the times. If the time to drain the tank is less than the time to fill the tank, then the compressor cannot keep up. So the time to fill the tank was 1.17 minutes. So any times less than that are highlighted in red. So again, you see exactly the same thing. If the fan is open more than about one full turn, the compressor cannot keep up. And the most interesting thing to notice from this table, in my opinion, is that almost all of the air is going into the fan, and very little of it is going to the nozzle in the center, the 1.5 millimeter hole in the center. And it's about a factor of 5 here from from a fan of 0 to a fan of 2 full turns open. It goes from 1.2 SEFM to 7.6 SEFM. So that's very important to know, in particular if your air compressor is not big enough to provide anything that your spray gun demands, which is going to be the case for essentially all small air compressors. And that's presumably the case for anybody watching this video. If you have a 230 volt air compressor, a large air compressor, you probably already know what you're doing, and you probably don't need to be watching this video. But for everybody else, it's going to be about basically adjusting your fan setting so that your air compressor can keep up. Now, if you go just a little bit too high, in my case, say I set the fan setting to 1.25, and the compressor cannot quite keep up, but it can get close. If you pause while you're spray painting, that pause time will give the compressor time to keep up, because it keeps compressing the air, even though you're not draining the air for that pause period. Now, I would be a little bit careful about doing that. You're going to be, pushing your air compressor pretty hard, and it's going to be getting hot, and I don't know. Like I said, just be careful. Okay, so we just learned the answer to what is an LVLP spray gun, and how is an LVLP spray gun different from an HVLP spray gun. And the answer is it just has a smaller fan. So all you have to do is take an HVLP spray gun and turn the fan way down, and so that you're going from a high volume of air down to a low volume of air, and then you can basically operate it in LVLP mode. Now, the fan setting is probably going to be more touchy. An HVLP spray gun, the fan from fully closed to basically fully open, that's going to be from 0 to maybe 12 or 15 SEFM. So a quarter turn on that spray gun is going to be probably about twice as much. It's going to be equivalent to like an eighth of a turn or maybe less on an LVLP spray gun. And also, the spray gun may be designed to use just a little bit more paint because you have a bigger fan pattern. So you're going to have to back off on the flow a little bit, but that's probably not a problem because you have 4 full turns of adjustment on the flow knob. However, my personal recommendation is to buy a spray gun that is pretty compatible with your compressor, or vice versa. Buy a compressor that is pretty compatible with your spray gun. And try and keep everything operating kind of in its nominal range. Okay, in step 3, we looked at what happens to the flow rate, to the airflow with different fan settings. So step 4 is to do the same thing with different pressure settings. So I set the flow to be full open, and I set the fan to be 1 turn open. And then I used 3 different pressures, 20, 30, and 40 psi. And you do exactly the same calculations as before. I'm not going to go through that again. And you get about 4.25 SEFM for 20 psi. And 5.46 for 30 psi and 7.47 for 40 psi. So roughly the amount of flow in SEFM is going roughly linearly with the pressure on your pressure regulator on your spray gun. It's not quite. Going from 20 to 40 didn't double the flow, but it was close. So if you have a small air compressor, you can try backing off on the pressure a little bit, but I mean, it'll help a little bit, but not a lot. I think your big setting is going to be fan. Now, in terms of going to higher pressures, kind of the nominal pressure is about 30 psi. Now, increasing the pressure may help atomize the paint a little bit and give you a little bit finer, nicer spray pattern. But It is a problem when you're painting small aluminum parts, like for an airplane. If you turn the pressure up, the higher pressure is going to start blowing your parts around, and it's going to blow them on the floor, blow them into each other, and basically make a mess. So you're either going to have to clip all your parts down so that they don't move, or you're going to have to keep your air pressure down. I don't see, for what I do, any particular reason to deviate very much from 30 psi. That's going to be my nominal starting point. Okay, now we know what our air compressor can do and what our spray gun can do. So it's time to hook them up and see what happens. I highly recommend that you start out with water. Just get a small container of water, a jar or something, and treat it exactly like you would paint. If you're going to filter your paint, filter your water. You don't really need to filter your water, but go through all the steps, just exactly like it was paint. And make sure you know exactly what to do. Make sure that you don't have any leaks. Water is basically free. It's dirt cheap. So, and just get a piece of paper and spray water on the paper, and you'll be able to see pretty well exactly what kind of pattern you're getting. Now, for this video, I used cheap latex paint so that I could actually take pictures of the pattern for this video. But you really don't need to do that. You can get very close with water. And then once you have your everything dialed in with water, when you go to use your actual primer or paint, there'll be just very small tweaks in the settings for your spray gun. So right before you start painting, you may want to use your actual paint or primer and spray some paper and make some very, very small settings, small tweaks to your settings on your spray gun. Okay, I started off by looking at the different fan patterns, and the spray gun was set to 30 psi. The flow was set to 3 turns open, and the distance from the spray gun tip to the paper was 8 inches. And I actually measured that and tried to keep it fairly constant. And the different fan settings are shown in the table here. It's a fan of 0 or fully closed in the upper left. And then going from left to right, it's quarter turn open, half turn open, etc. And you're getting pretty much, exactly what you would expect. As you open up you're starting off with a circular pattern, and then as you open up the air on the fan, it is blowing the pattern into a vertical oval, and the more you open up the air on the fan, the bigger oval you're going to get. The paint stick on top is 12 inches, so that's there for scale. I thought that I was clearly getting some runs on number 2 and number 3. And so I decided to back off on the flow and repeat this. So this is the same thing except with a flow 2 turns open instead of 3 turns open. And you're getting pretty much the same pattern as before. And remember that for fan settings greater than 1, so that would be greater than 13 in this picture, my compressor cannot keep up. So I want to keep the fan somewhere between 9 and 13 in this picture. Okay, this is comparing the spray gun 9 through 12 that we saw in the previous slide, which is fan of 0, 0.25, 0.5, and 0.75 to just a can of spray paint. The can of spray paint is the brown on top, in the top row. And of course, a can of spray paint just gives you a circular pattern. And the different patterns are just the different. I changed the distance from the can to the paper, and the one on the left was an 8-inch distance, then 12 inches, 16 inches, and 20 inches. So there's basically no reason at all that you can't use your spray gun with the fan turned way down to emulate a can of spray paint. And you can do a quite decent job of painting with just a can of spray paint. You might not want to paint your car that way, but you know, if you have a scratch on your bumper or something, you could just touch it up with a can of spray paint and actually do a fairly decent job of it. And if you don't have a very big air compressor, you can turn the fan setting down pretty low and you know, still be able to paint parts. You're probably going to want to do what I did. You know, I increased the distance, and so if you're running with a fan setting of a very small fan setting, you're probably going to want to back off and use a distance greater than 8 inches. Okay, here I have set the pressure to 30 psi, the fan to 3/4 of a turn open, and the distance is 8 inches, and I've changed the flow, and it goes from 1 turn open to 2.5 turns open in half-turn increments. So, you know, clearly when you're getting up above 2 turns open, you have a greater propensity for a run. Now, it depends on how fast you're moving your spray gun. In this case here, I was not moving my spray gun at all, so the paint is tending to build up and run. So it may not be quite as bad as you might think. But probably you don't want to be have your flow turned up higher than about 2. Okay, here the fan is fixed at 3/4 turn open. Flow is set at 2 turns open. Distance is 8 inches. And I changed the pressure on the pressure regulator at the spray gun. And I went from 20 to 40 psi in increments of 5 psi. And I don't see big changes. And as I've already mentioned, I don't see any big reason to deviate from a nominal value of about 30 psi. And it's probably okay to turn the pressure down a little bit if you have a smaller air compressor, or if you want to keep from blowing your parts around. So, but I would probably not go below about 25 psi. And unless I had a good reason, I would probably not go above 35 psi. Okay, here all I did was change the distance from the tip of the spray gun to the paper. And the picture on the left is a distance of 8 inches, and the picture on the right is a distance of 12 inches. So, of course, as you get further away, you're going to get a bigger pattern. But probably what you want to do is, the exact distance you're using is probably not that important. What you want to do is just be consistent. So if you want to spray at a distance of 12 inches, just set everything up, for a distance of 12 inches. Set your flow and your fan, for using that distance. And I thought everything was getting dialed in pretty well. I was reasonably happy with pressure of 30 psi, fan of 3/4 turn open, flow of 2 turns open. So I just did a couple of passes on the paper. I did left to right and then right to left with about 50% overlap. And I thought that basically it came out okay. So these are my default settings. And now when I go to actually spray paint or primer on something, I'll start out here and just tweak it from there, make small changes. Okay. That's it for this video. If you watched both of my videos and you made it all the way through to the end of this video, you probably now know more about spray painting than about 99% of the people, the so-called professionals making YouTube videos about how to set up a paint spray gun on YouTube. I did go into a fair amount of detail, and I would be interested in your comments on that. Was there too much detail, but I hope that you did find it useful and interesting. If you like these videos, The thing to do is to subscribe, give them a thumbs up, or leave a comment. And that will tell the YouTube algorithm to recommend them to other people. And as always, I will put links in the description. Now for this video, probably the only link is going to be a link to my previous video, part 1 on spray painting. So that's it. Thanks for watching.